In this video, I'll introduce you to the idea of joint probability. Joint probability is the probability of two events happening together. The two events are usually designated Event A and Event B. In probability terminology, it can be written like this. We have small p, that's our probability of A and B happening together. Or we can use set notation and write a cap instead of the word and. We can also describe joint probability as the intersection of two or more events. The intersection can be represented by a Venn diagram like this one. We have black things and white things, and here's our intersection. Cats can be black or white, and hair can be black or white. So this central area is where we're going to find our joint probability. Let's take a look at an example. The probability a card is 5 and black from a standard deck is 2 out of 52. We have 52 cards in a standard deck, and 2 of them are black, the 5 of clubs and the 5 of spades. If we simplify that fraction, we get 1 out of 26. We can also show joint probability in a table. A joint probability distribution shows a probability distribution for 2 or more random variables. Instead of events being labelled A and B, the norm here is to use X and Y. The formal definition looks like this, but the whole point of the joint distribution is to look for a relationship between the two variables. That's all this formula is trying to quantify, a relationship between X and Y. For example, this table shows some probabilities for X and Y happening at the same time. You can use the table to find joint probabilities. For example, what is the probability for Y equals 2 and X equals 3? To answer that, we look at the table for the intersection of Y equals 2 and X equals 3. The answer, 1, 6, is circled here in red. You might also come across the joint probability mass function. If your variables are discrete, like those in the table, y equals 1, y equals 2, those are discrete counts, their distribution can be described by a joint probability mass function. Basically, if you have found all probabilities for all possible combinations of X and Y, like shown in this table, then you have created a joint PMF. It gets a little more complicated if you have continuous variables. Instead of a joint PMF, we have a joint PDF. That's a joint probability density function. Unlike the discrete variable example in the table of counts, you can't write out every combination of every variable because you would have infinite possibilities to write out for continuous variables. That is, of course, impossible. But what you can do is create a formula. And the formula that describes all possible combinations of X and Y is called a joint PDF. If we have two random variables, X and Y, we can define the joint PDF as the partial derivative of a function of X and Y with respect to X and Y. Finding partial derivatives is a fairly advanced concept in calculus, so I won't go over that here. But just to clarify, there's two types of densities. You have the joint PDF, which is for continuous variables, and then you have the joint PMF, and those are for your discrete variables. I hope you found this video helpful. Please take a moment to subscribe to my channel, and I'll see you in the next video.